Hello, everyone. Want to say good morning, good evening, depending on where you are. This is Steve coming back with another video. I'm going to keep this intro short so we can move right into this to save some time. So today we're going to be discussing the Commodore 64's memory, which is 64K. Think of it as 64 times 1024, or basically it makes up the total of 65,536, and that's how many registers can be stored on the Commodore 64. So, for example, whenever you type in like a POK 646,2, this first digit right here, this is where it's going to store in all the memory locations, where the bytes are stored, and they go, let me just change this, they go from 0 to 65,536, excuse me, or that's 64 times, where is that, times 1024. And if you just wanted to do the calculation here, 65,536. So that's how many registers can be stored on the Commodore 64. Now, BASIC can only carry 38,911 bytes. Bytes is spelled that way. And essentially the difference between that is 38,911. So 2,000 or 26,625, I believe that's left for ROM and other things. BASIC doesn't really give you full advantage of your Commodore 64's memory, but it is what it is, and we've got, what we can use with it. So what we're going to be doing today is we're going to be discussing screen memory, and I'll be going over that in a little bit. Before I do that, I wanted to explain a little bit more about this memory so that people can kind of get a grasp on this. So I came up with a kind of a weird example, I guess. Your brain, for example, has brain cells in it, right? It has millions and millions of brain cells. The Commodore 64 doesn't have millions and millions of cells, but think of it as these cells is translated to mean bytes, essentially. So these bytes in memory is how much memory your Commodore 64 can consume up here. So 65,536 bytes, or 65,536 memory locations that you could store. So it is possible to type in 65,536, 1 with, oh, actually, you know what? It's probably 5. Let's see. Yeah, I'm sorry, because it starts at 0, so it's 5. So you can store up to that many locations in your computer's memory. I think that one might be in ROM, so we won't be able to look at it. Yeah, that's just a ROM location. But be very careful about which ones you mess with. Some of them can lock up your computer if you're not very good at that, and I'll show you an example of where I'm getting this. Okay, so this book, I've showed it many times before, Mapping a Commodore 64, is where I'm getting all these registers, and they start from 0, and they go all the way up to 65,535 because of the 0. And here's the first one. You'll see page 0, right there where you see the 0 there, right here. Where you at, right there. Right there, the 0. That's the first register in the Commodore 64's memory. You could type in a POK 0. In this case, it probably won't hurt you since this is a working storage of BASIC, but it might mess up something in BASIC, so I'd be careful. And then it goes all the way up to 65,535, but this book doesn't probably go that far. This book goes up to 65,534. I'm not sure what the 65,535 is all about, but you can see that's where I'm getting all that. And those are all slots in your memory, or think of it like those brain cells you have. And think of it also that each brain cell we have is tasked to do different things. Some are for vision, some are for memory, some of them are just for different things individually. Hearing. So your Commodore 64 too may not be able to see things and be able to hear things, but it can remember things. So I thought that was kind of a good thing. It also has other actions it can do with memory. It could sit there and throw sprites on your screen. It can control the screen in general. There's a lot of things in there. It can control your disk drive, everything that your brain of your computer can actually do. So hopefully that makes a little bit more sense, and let's get started here. Okay, so I'm going to show you how to put something into the computer's screen memory. And this is going to make something appear on the screen. First, I'm going to erase my screen. And then you're going to enter memory location 1024 and then put 65 after it. And press enter. Actually, that was not what I meant to do. Actually, maybe a 1, I'm sorry. I'm thinking of different memory here. One second. Okay, so we turned on an A here in screen memory. So if we go and we print into that memory location, we will see the one that we just entered. So whatever we put in that memory location is going to change. So it's basically looking through your memory, computer's memory, at what's basically a character set in the memory there. You can see it changing. So the character set is able to remember from 0 to 255 characters. So if I go in here and I type in, I probably showed this before, but if I type 255, you'll see a strange character there. If I type 256, I'll get an error because you can't go beyond that. Now also on your screen here, it's made up from 0 to 999 areas of character positions in memory. It's actually, if you think of it as 1,000 character positions, if you count to 0 and just start at 1, it'd be 1,000 character positions that are recorded in the memory there. I'll show you the bottom corner here. We'll put a 1 in there. Now you see the bottom there. And we just restore the top. We'll see it at the top again. So that's from the bottom to the top. That's 0 all the way up to 999 plus. So 0 to 999. For a total of 1,000 if you start at, 1. So keep it that screen memory, and also each character location here you're seeing on the screen. So if I had a way to zoom in on this, I could show you these characters are made up of 8 by 8. And I have an example here. Kind of skipping around here a little bit. This is what I'm referring to. This is supposed to be my imaginary letter A. So if we just put a letter A on the screen here, just kind of look at it here for a second. Let's put it over here somewhere. And if you could zoom in on it, you would see it's filled in with little characters. That's what makes it look like a letter A. Now these can be changed later in something called redefining the character set, but that's a little bit more advanced. So what we're doing is we're just basically turning on bits in the computer's memory. If you remember the binary from zeros and ones, 0 turns off a bit. So this area right here would be a 0, and this would be a 0. Sure that negative 1 came from. And this would be a 0, and this would be a 1. If I had to put it in the middle here, I'd put a 1 here or something like that. And this would be a 0, and so on. So that's how the binary number would make up that row, and then you just basically add it up. And if you use the binary calculator, you could actually, or just a calculator in general, you could calculate it. Okay, so I wanted to show you something. I broke this down into zeros and ones for binary. So every time you're seeing something in the screen there, in the field here, like you're seeing in this letter A, where it draws the letter A, that's going to be a 1 whenever it's lit. Think of it like the light bright, if you remember that. And then our light turning on and off, this is going to be lit, this is going to be off. So anything around this A would be zeros, and anything inside of it would be the ones wherever the A is being drawn. That's a binary. And here's how it's calculated if you want to see it. This is just the calculator already built into Windows 10. So we'll do the first example, and I'll show you where I got that. So you just type in the binary equivalent for it. Oops, where am I typing at here? 0, 0. 1 second. Okay, so I realized it was truncating the zeros at the beginning. So you won't see these zeros, but this is the binary equivalent if you add the zeros into it. We could do, there's none of these that start with a 1, so if I can do that. But anyways, anytime you type in that equivalent, it's always going to show that binary number. And you can see the binary number here, and you can see the decimal number here, 68. So that's how the screen is made up of the pixels that you're seeing on the screen. I thought I would show that to you. And going back here a second, I'm going to show you all the locations in screen memory here. I just made this simple example chart. So think of every time you're in this square up here at the corner, for example. This is 1024. This is 1025, 1026, 1027, just like you're seeing here. So these are being lit up every time I'm going through these rows here. So hopefully that makes sense to you. And those are the registers that's turning on those locations. Trying to get it to work here. Okay, so yep, that's how you do screen memory. And anytime you poke a value in there, you're going to get it. Now the next thing we're going to learn about here is color memory. Oh, and also I should mention that each row here goes from 0 to 40. So if you count them over, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 4, 5, 6, 7, 8, 9, 40. So it goes by 40, and it goes by, what is it, 25 rows. So 25 from the top. So if you had to count down 25 from the top, let's put in the center. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and the 25 will be at the bottom there. If I do another one, it's going to scroll the screen there. So that's how the computer is made up of, we'll just say the columns or whatever, or the, what I put, the columns will be 40. And then the rows is 25, like that. Okay, so that's how your computer's memory is made up, and you can poke into any one of those areas, as I mentioned, from 1024 up to 2023. And I showed that in the chart here. In the bottom right corner here would be the 2023, upper left is 1024. So kind of moving ahead here. We covered a lot of this already. Now we're going to learn about color memory. Color memory is very similar to what we just did, except it starts at 55,296. You can see this one right here. I'll color that in to show it to you. Oh, not the one I wanted. One that you can see it there. So that's going to be 55,296. So if I go in here, and it's corresponding to these memory locations of 1024, and it's storing a value in this upper corner. So we'll restore that one back up in the corner there, and then right after this, we're going to type that number we see it highlighted on the screen, 55,296, and we're going to enter any value into it. We can enter 0, whatever, and you notice that the A turned black. Why? Because this is what's called color memory. This is where your computer is storing the same amount of memory from 0 to 999 or 1,000 bytes total of screen color memory, or color memory, I'm sorry. So if we change this, any value here, we can go up to 16 or 15 here. 0 to 15 is 16 if you start at 1. If you go back to 16, it'll just flip back to 0. This defaults back again. But any time you put something in here, you're going to see that color turned on. That's the background, so you can't see it. And then that's the red we already have, and so forth. So that's how you get the screen. We already know about the background, so if we wanted to turn it black, we could just do that. And then we could just play with it some more. Actually, let's clear the screen here a little bit. It's going to sneak in here. Oops. I just wanted to show you in color there. Now you can see the blue A because the background's no longer blue. So I didn't want to make these videos too long. I'm trying to shorten these now, but I wanted to at least show you that example, and then we'll try to come up with a simple example here. And the next thing I'd like to be able to do is go over animation. If I go into animation, if I don't split these up, these are going to be very long and complicated for people, and I don't want to do that. So we're going to save that for next time, and I'll get the program here. Okay, I'm back with a little example here. I'm going to go ahead and run it, and then I'll explain it. So what you're seeing here is the reproduced A on the screen as the computer would see it in memory. So see, we've got the 2 at the top here, and then we've got the 1 here with the space missing here and the space missing there, and then the 1, 0, or 1, 1, and 1, that's right there. And then we got these rows 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then down here we got 1, 2, 3, 4, 1, 2, 3, 4. So it draws the letter A. I just basically changed the colors to show you how you can change the colors of on the screen. Now let's go ahead and look at the listing. Unless it's just listed, doesn't matter. Okay, so we're familiar with the top part here. This clears the screen, as always. This is just changing the color of the screen background to black, and this is just changing the border to blue. The next thing here, where it says for x equals 1242 to 1242 plus 40 times 1, remember when we learned about the uppercase being 1024. Now if we go down here, for example, and we type in Let me just do this. Let me clear the screen real quick, and then just list those lines so I can show you what I'm talking about. What to say, 30 to 40 I think is good, or 50. So we can see the lines, and then we'll play with that location, 1242, comma, 81 is the example we use. And you're seeing a blue thing, I'm sorry, you're seeing a circle turn on here on the screen. So you see where it says 1242 to 1242 plus 40 times 1. Why is this necessary? Because remember, it goes from 0 to 40, so it's basically, or 0 to 39, it's from 40 columns over times 1 so that we can draw the next line down. That's why you're seeing two colors there. When I run it again, you'll see that there's two red ones here at the top, which is equivalent to this one right here. This 2 is poking in a color memory. I'm sorry, this is poking in the, this is poking into character into 1242, and the 1242 plus 1 gets it down to the next line because of step 40. Step 40 is a way of jumping down 40 lines. Instead of being at this 40, you'll jump down this one. So every time you see 40 times 2, it'll go down 2, 3, and so on to however many you see. That's how you draw it down the screen. You have to use that pattern, though, 1242, to figure out the screen location, to how far you want it to go. So it basically looks like I'm going in this, not going anywhere, and technically I'm not. Reason why, and let me just list this again to explain that. The reason why is 1242 plus 40 times 1 is, oops, I've got to print it. Tried to poke it. Is 1282. So if we take 1242 plus 40, we'll see it's 1282. So that basically is doing this. So if you take 1242, 81 and 1282, 81, you'll see it draws it on the screen. So it's just drawing one on top of the other by going down the screen. By using our step 40, it steps over 40 lines to get all the way to the next 40th position, which starts right here. And that's how you get it to draw down the screen. So if you wanted it to go all the way down the screen from the top of the screen, for example, we'll just use, I guess, 1024. 1000, let's say, x equals 1024 to 1024. And then you're going to say plus 40 times however far down you want it to draw. Let's say you want it to go to 12. And you use the step 40. And then we're just going to throw in a value into x. We'll just make it an A, I guess. And then we'll turn on our background color. I'll explain that here in just a second. And then we'll just next it. And you'll see it draw all the way down the screen here. See how it drew the A straight down the screen? Basically, it's just taking that 40 times 1, times 2, times 3, times 4, times 5, times 6, times 7, times 8, times 9, 10, times 11, times 12, which is exactly what you see here, times 12. And that's how you get to draw down the screen. So the next example here, and also this right here is the color where you see plus. I'll clear it again and show it to you what I mean. So it's easier to focus on those lines. So we already know that the x is going to be 1242, 81, the first position. And then the next one here says x plus 54,272. Remember, x is 1242, so if we say poke 1242 plus 54,272, 2, we see it turn red. And why? Is if we print this, 1242 plus 54,272, we'll see our color memory there, 55514. And if we had to look in our color memory map earlier here, we'd see, or where's it at, down here? Down here, we basically figure out where it is in here in color memory and then draw it. Now, I don't have enough room to draw them all on here because they'd be very large, but that's essentially how they're done. There's a close shot for you so you can kind of see how they start here from 55 to 96, and then here I'm basically just drawing on the color memory. And then on the back here, I believe is, yeah, this is the color, the screen memory here. So you can kind of see a little bit better there. So it focuses. See 1024, and it's going all the way over here. It's just drawing in all those pixels, and those pixels is where that circle is appearing and where any characters I type on the screen is appearing. That's all you're seeing there. Okay, so moving on to the next lines here. You can probably see a pattern by now, but I'm just going to show you anyway. I always try to break down as much explanation as I can, even though I didn't want to make this super long. So for x equals 1321, 1321 plus 40 times 2, step 40. Once again, 1321, we'll set the 81 in it so you can see the circle there. If you remember the earlier one, it's 1242. And then we got the next one down here. Hook 1242 plus 40, since we're going down 40. And you'll see the next one down there. And then this one over here is actually adding 2 more over. So if you take 1240 or 1321 plus 2, what do you get? 1321 plus 2, 81, gives us the next position there. So that's all we're doing, is we're just drawing wherever those screens are being highlighted, as I just showed you earlier in the screen memory there. Right here. And it turns on the screen color for individual characters. And of course, the values out here, you see X plus 54272. It's just turning on that color memory. So anytime you set it to 1321 or any value that starts at 1024 to 2023, you can do the plus 54272 to find that area color memory. I'm sorry, that color screen memory. Color memory, excuse me. To turn on those bits. And that's essentially all we're doing for this program. We're just going right through it, and we're just turning on those bits. Again, this one's just turning on 1400. You need to see it. I will go ahead and go through this since it's a very basic tutorial. So we just covered that one. So we'll go to 90 to 95, I guess would be good. And these ones are pretty simple. 1362, 81. So I poke it in, you'll see them. So I don't erase it. I'll put the other one after here. Oops. I turned on 18. Oops, I hit the wrong value. You see what I did? Is it turned on a totally different area. We don't want that, but that's basically how you get it to turn on different areas. And I also turned on a different character. So there we go. And then we'll go down here so we have a little bit of room. I just can go up a little bit. 1362 plus, where's the plus? Plus 54, 272, 1. You see the white turned on there? And then we're doing the same thing over here, except we're turning on the digits beside it. And you can see they're both red. Now if I wanted to change them to it, another color, I could. Now they're blue. That's what that line does. And now we're on to 100 through 120 is good, I guess. So we did this earlier, but we're basically just turning on 1400, 81, and then that's just the bottom part of this letter A going across the screen here. And then I'm sorry, just drawing these lines these on the side, I believe that's what it's doing there. So the 1400, 81, and then we say 1400 plus 40, 81, and you'll see it draws the next line down, and then we just repeat the same pattern. This might go off the screen now. Yeah, this is going to go off the screen if I type that in. So we'll put it down here, so we have some room. So 1400 plus 40 times 1, 81. Oh, I already got 1, sorry. 2. There it is, it's underneath there. And then, of course, 3. And that's how we get the lines going down the screen. And then we can change those colors too by doing the same thing. Poke 1400 plus 54. Actually, you got to copy it this one. 40 times 3. And then you got to say plus 54, 272 to turn on the color value that you want to turn on. And you see it turned on the last color here for white. Whatever color we want it to be is what color it will be. And so forth. So hopefully that makes sense. And the last part here would be lines 130 through 140. And these were pretty self-explanatory. Just type them in. And you'll see the cursor appearing on the screen there. Or I'm sorry, the circles. I have no idea why I keep saying cursor. And then we can turn on the value there. Any color we want. And ignore 140. That was going to be something else. But that's basically it. That's how you draw on the screen. So just going back again, remember the binary digits is how you identify what's inside of those pixels, and the computer is basically drawn inside of the screen memory from 1024 up to 2023, as you see right here in this example right there. So I hope this made more sense to you. We'll move on into some other examples real soon. Okay, so I'm trying to keep these videos as short as possible. That one went a little bit longer than I expected. I hope you guys enjoyed this. Please like, favorite, subscribe as always. And this is Steve Morrow, and I look forward to hearing your feedback real soon. Thank you for watching.